Okie dokie, here we are for part 2 then of projectiles. So still in this book, and as before, the book does a number of work examples which I'm not going to use. You'll find them on page 85. I'm just going to go straight to the exercise and do a few of the exercise questions. The big difference between what the book does and what I sorry, it's all the medication I'm taking. What I do is that the book insists on using I and J notation, and as you know, I'm a column vector man. But yeah, there's no difference really, is there? There's just two different ways of writing the same thing. So page 87, we're going to start on question 1. And really, there you go. If you haven't got the book, that's the question we're going to do. Really, there is nothing different here than what we were doing in the first video, which I did this morning. It's just a different way of presenting the problem. So we are told that this particle is projected from a point on flat horizontal ground, and rather than telling us its speed, let's choose the colour that works, rather than telling us its speed in terms of magnitude and direction, it's telling us it's a vector of 12i plus 16j. And what that means is that it is it's got a horizontal component of 12 and a vertical component of 16 meters per second. And we can use those numbers separately in horizontal and vertical Suvat equations, just like we were doing a moment ago, or we can use vector notation in the Suvat equations themselves. And that's what I'm going to do. But if that confuses you and you'd rather just continue working separately in horizontal and vertical directions, then there's nothing to stop you doing that. Let's just work out the speed and angle of this one just for kicks. It doesn't actually, we don't actually require to do that, but just work out the actual magnitude of the speed and the angle for me before we do anything else. I'll pause at this point. So there we go. We know it's actually 20 meters per second at an angle of 53.1. Pythagoras to work out the magnitude and shift tan to work out the angle. So, you could just stop this video now and do everything in the way that we were doing a moment ago. I suggest you don't, because actually this is so much easier. If they give you the information in vector notation, it makes it so much easier. So if we have a quick look at Suvat, we know that distance or displacement is a vector. It will have a horizontal and a vertical component. Initial speed and current speed will. Acceleration, yep. So if we're using column notation, acceleration is 0 in the horizontal direction and minus 9.8 minus g in the vertical direction. T is a scalar, T is just time, so it has no direction. Yeah, some of you will be saying, well, yes, you can have a time going forwards and backwards. No, T is just a scalar quantity. So in this question, we're asked to say its velocity 2 seconds after projection. So we've got its initial speed. I'm wishing I'd left myself a bit more space here. So its initial speed given to us in vector form was 12/16. And we want to work out its current speed. So S not involved in this question at all, so I'm going to use V equals U plus AT. And I could do this separately, horizontally and vertically, but I'm choosing not to. I'm going to say, right, V is equal to the initial speed and so that means that V is equal to 12 plus 0t, and the vertical component 16 minus 9.8, sorry, t is 2, isn't it? So it's 16 minus 9.8 times 2. and that's in meters per second. And there's nothing wrong with writing in a question with vectors. There's nothing wrong with writing it like that. Or I guess if they'd given it to us in IJ notation, we ought to write the answer in IJ notation. And let's again, we're not told, but let's just work out the magnitude and the direction of it. So that's 12 along, 3.6 down. So again, it's just usual Pythagoras and inverse tan to work out those two. I'll pause and do that. Okay, so we've got 12.5 meters per second at an angle of 16.7 degrees below the horizontal. Now, okay, I've been a little bit less than rigorous in my use of the words speed and velocity. So speed is a scalar, it's just about the size at which it is of the speed it's travelling. Velocity has direction. So, yeah, I really ought to be clear, hadn't I? So, 12.5 meters per second is its speed, and that's made up of a horizontal velocity of 12 meters per second and a vertical velocity of minus 3.6 meters per second. Its initial speed was 20, which was a horizontal velocity of 12 meters per second and a vertical velocity of 16 meters per second. So a question like this would ask you for the velocity. So this is velocity because you are giving it as both horizontal and vertical components, whereas the questions we were dealing with previously in the previous video, we were working out speeds, which is the diagonal. So vector questions will tend to talk about velocity if they want the answer in vector form, and speed if they want you to go through the process of turning that into that. And be clear that question one, the question we're actually doing at the moment, doesn't ask for that. So I've only just done this bit as a little optional extra. Now part B and C are sort of trick questions because they say find the particle's velocity when it reaches its maximum height. Now we know that when we want to work out the place or the time where it reaches its maximum height, we just ask when is its vertical velocity 0. So I already know the answer to that in terms of this number will be 0. So the only thing I need is the horizontal velocity at that point. Well, horizontal velocity is always going to be 12 in this question, because when we are modelling this thing as a particle, there's no acceleration or deceleration in a horizontal direction, so it's always going to be 12. So that's the answer to part B without any calculation at all. And part C, well, this journey is symmetrical. So if it was asking about the time, for example, the time to the top is the same as the time to the bottom. And the same is true of velocity. So its horizontal velocity is going to be 12 forever. Its vertical velocity as it comes down will be the same as its velocity when it left the ground, just in reverse. So that's the answer to part C, or in IJ notation. That. Now I'm going to add a sub-question to this, part D. Part D says, what's the time at which it reaches its maximum height? So part B was what's the velocity at its maximum height? We could just write that down. What's the time when it reaches its maximum height? Well, time is a scalar, and I know this is only to do with the vertical direction, so I'm actually going to revert back to normal non-vector suvat for this. So I'm just going to say, okay, I want to know its time when its vertical velocity equals 0. Its initial vertical velocity is 16, and it's accelerating at minus 9.8 meters per second. So I'm going to use v equals u plus at again, but I'm going to do it in a non-vector form because I'm only worried about the vertical direction. So 0 equals 16 minus 9.8t, so 9.8t equals 16, so t equals 16 over 9.8, which is 1.63. Supplementary question, part B. Find the total length of the journey. Well, do you remember what I said about symmetry? So if that's the time it takes to get from the bottom to the top, then the total journey will be that doubled. And if you store the exact value for that, then double it, then you'll get there we go. Okay, let's have a go at another question. Okay, so here's the next one I want to do. Question 3 on page 87. Screenshot that if you haven't got the book. So we're now talking about a stone that gets launched, but this time it's launched from a height of 2.5 metres above ground. So it's launched from this height here, and it is launched with velocity 6,9, so that's 6 and 9. And we're asked the length of time that the stone is at least 6 metres above the ground. Well, it's already 2.5 metres above the ground. So I'm going to do this by just working vertically. So we know in the previous question we did it by using Subat with vectors. Now this is just a vertical question, isn't it? Because I'm asking if my initial, I'm going to call the initial height 0. So I'm going to say, right, it is, how long is it 3.5 metres above where it left the ground? So I'm going to ask, when does the vertical distance equal 3.5? Now this journey is going to sort of go like that, isn't it? So this is not to scale, but started 2.5 metres above the ground. I'm asked, how long is it? 6 metres above the ground, which is 3.5 metres above where it started. So there'll be 2 answers, here and here, and my answer will be the difference between those two. So its initial vertical speed, so I'm not worrying about vectors now, just thinking about the vertical component, is that. Don't know what the speed will be at that point. There we go. So I don't know v, so this is going to be s equals ut plus half at squared. So, well, there you go. I'll pause it. You should get a quadratic in t. And solving that quadratic will give you the 2 points when it is 6 metres above the ground. See if you can have a go at that. Okay, so even though I was in the equation solver, in fact, let me go back into the equation solver and get those answers up. So when you've got answers like that, you can S/D it. So I just sort of wrote down plenty of decimal places, and yeah, so I just did that, take away that to get my rounded answer. Okay, the distance by which the stone falls short of the target. Well, this is still a vertical problem because the time is the first thing I'm going to work out. So I'm going to work out the time that it hits the ground. And so I'm still thinking vertically, sorry, I'm going to move down here, because it will hit the ground when its distance travelled is minus 2.5 metres vertically. So everything else is and again I want to find the time. Now the model, obviously it's only going to be at minus 2.5 once, but I'll probably get a negative time. Well, I say probably, I will get a negative time because the Subat equations don't know that it started at 2.5 metres, so there'll be a negative answer which I'll ignore. Now, of course, this isn't going to give me the answer to the question. This is just going to give me the time. So I'm going to do exactly the same again, and I'm going to store that value when I get it. So yep, another pause and go for that. Okay, I'm being ridiculous here by writing it down to so many decimal places. That's not the final answer. What I'm now going to do, I've worked out that's when it hits the ground. I'm now going to work out how far it's travelled horizontally in that time, and that will allow me to work out how far short of the target it is. The target was 20 metres away from the window. So see if you can do that. We need to switch to horizontally, and we need to work out how far it will have travelled horizontally in that time there. Pause, never go at that one. So really easy when you're working horizontally, because acceleration is 0, so that's nothing. Although interestingly, I rounded that to 3 significant figures. So I was 7. Remember, the target was 20 metres away, so I was 7.5 metres short of the target. But of course, that's 2 significant figures, so I had to sort of go a little bit more accurate there. But it was all on the calculator screen, so that wasn't a problem. So we've done 2 questions now. One where we worked with Suvat equations using vectors. One where we did separate horizontal and vertical resolving. How do you know which one you do? Well, you can do it this way, which for either, but I guess questions where you're asked for velocity or where you're asked for distance travelled, where there's 2 parts to that, the vertical and the horizontal part, sometimes the vector approach will be easier. Here's the next question, question 4. Okay. So here we're told that a golf ball is hit off the edge of a cliff, and when it is hit, it has an initial velocity of AB. So we don't know. But we know that it lands 200 metres away horizontally. So that means that the distance that it's travelled when it hits the ground, I can write as a vector, because it's travelled 200 metres horizontally, but the fact it's hit the ground means it must now be 40 metres below where it started. So I can do this one in vector form, and the time is 5 seconds for it to do that. Now I could do this separately, horizontally and vertically. I absolutely could. There's nothing to stop me doing that. But I want to know A and B, so I've got. So this is going to be another S equals UT plus half AT squared, and so 200 minus 40. I tell you what, rather than me doing it for you, why don't we pause at that point and you have a go? So I wrote out my Suvat equation replacing S, U and A with the vectors, and T is 5, so T squared is 25, and so AB times 5 is 5AB, and this I've got a half times 0 times 25, which is 0, and a half times minus 9.8 times 25, which gives me this. And so now I can just read off the vertical and horizontal pieces separately. So looking at the horizontal numbers, 200 is equal to 5a, so that means that a is 40, and a little bit more complicated going this way, but not impossible. So minus 40 equals 5b minus 122.5. So minus minus 40 plus 122.5 equals that. Divide that by 5, so we get 16.5. So we A and B, if you remember, were the initial velocity. So we now know that it was launched at 40 and 16.5 meters per second. part B of that question wants to know the velocity of the golf ball when it hits the ground. Remember, velocity is vector. So again, I'm going to do this one in vector form. And actually, I'm not going to even bother putting up a fresh SUVAT thing. So I'm just going to say I now know what A and B are. And I want to know the velocity. So I can pretty much use any equation because I've got them all here. I mean, one thing actually, v squared equals u squared plus 2as, which we hardly ever use anyway. We don't use with vector form because squaring vectors is a bit of a funny one. So anyway, I wouldn't use that anyway. In this case, I'm going to use v equals u plus at. And again, I could do, if this vector thing is confusing you, I could do it separately, horizontally and vertically. But I want to know the velocity 5 seconds after it's launched. That's what they're asking. So and so yeah, we know that this is going to be 40, don't we? It's always going to be 40. There's no acceleration or deceleration horizontally, and 16.5 when t is 5. So you've got 16.5 minus 9.8 times 5. And it asks for the velocity, so it just is perfectly okay to write that in vector form or in, and I would always do that if the question used that. If it asked for speed, which it doesn't, but if it asked for speed, then I would have done the whole Pythagoras and shift tan thing to work out the magnitude of the speed and the direction. Okay. Now I sort of hope you're thinking, well, okay, yeah, there's nothing really super complicated here. How can it be made more complicated? And hopefully it won't be. Hopefully, you'll get a nice easy question with motion under gravity. It mentions projectiles, so we know there will be a projectile question. Will there be two? Do those two references in the pre-release? I've got it here. Do they talk about one question or two questions? We don't actually know, but you can get a question like question 6 on page 88. So again, if you haven't got the book, here it is. So you can screenshot it. In this one, we've got something which isn't moving under gravity. So in this case, we've got a model submarine moving underwater at a constant depth. So that's interesting. So it's not going up or down. Instead, this question is about east and north. Now that's a bit confusing to me, but I guess what they're talking about is this, isn't it? So this is the I direction, that's moving east, and that's the J direction. So they're sort of setting up a sort of you're looking down on it rather than looking sort of side on a projectile question. So anyway, I'm going to give you a minute just to, well, you can have as long as you want, it's a video. I'm going to pause, give you a minute to get your head around what the problem is, and maybe set up the SUVAT thing you need to answer part A. Okay? Okay, so I've set up this problem. It's hard to get your head around what's going on here, but the question part A, as it says, when will it be moving due north? Now, due north, in this context, is when it's only got a J component of speed. So there's no I component. So it means that the speed here will be 0. We don't actually know how fast it will be moving north. So I'm going to just look at this problem initially horizontally. And I'm going to say, right, I've got u, v, a and t, so I'm going to use v equals u plus a t, and I just want to know when does its horizontal velocity equal 0. Slightly different context here, isn't it? So this is why I've got to be slightly careful. Its initial horizontal velocity was minus 0.6, and it is accelerating in a horizontal direction at 0.1 t. So hopefully you can see that t equals 6 seconds. Find the approximate bearing on which the submarine were moving when t is 2.5 seconds. Okay, so that was part A. So part B wants to know the bearing at which it's moving. So that's about the speed and the direction, isn't it? So I need to work out its velocity 2.5 seconds later. And because this will be to do with both directions, I need to use vector notation or do horizontal and vertical separately. So I'm going to set it up. I'm going to use v equals u plus at again because s isn't involved. And v is what I want to work out. U is the initial velocity. And I'm going to do that. So a times t, so that's that times that. So that's 0.25 and 1.25. So this is minus 0.6 plus 0.25. That's minus 0.35 and 3 and 1.25 is that. So that is going that way. This is not to scale. And that way. So it is travelling in that direction. Now remember, a bearing is the angle clockwise from north. So if I use shift 10 to work out that angle, I need to do 270 plus that angle. So I'm going to work out that angle there. Okay, so shift 10 of 1.25 over 0.25. So it gives me 85.29 or 85.3. So if I add 270 to that, that gives me the bearing, which is 355 degrees, which is the direction it is travelling after 2.5 seconds. Okay, so last part asks for, part C asks for the distance it's travelled, which will have a horizontal and vertical component. So I'm going to do this in vector form. V isn't involved, so I'm going to use this equals ut plus a half at squared. So after 20 seconds, so go on, plug it into that formula, see what you get. So you can just work it out separately. So in the easterly direction, I keep saying horizontal vertical, it's not, it's east and north, isn't it? But you get 0.6 times 20 plus a half times 0.1 times 20 squared. I got that to be 8. And you had in the y direction 60 plus a half times 20 squared, which I got to be 160. So that means that in this time it has travelled 8 along and 160 up. So the distance that it's travelled, just a simple little bit of Pythag. So it's 8 squared plus 160 squared, square rooted, and that gives me 160.199, 160 metres. The question finishes with one of those frustrating sort of non-maths questions. I guess you could use 3D vectors because you're actually dealing with something moving underwater, so it might not be going at a constant depth. and I imagine that acceleration in water is unlikely to be constant, so you might be able to model it using variable acceleration. So I suppose that's another improvement you could do. So on page 89, question 9 is a pretty sort of complicated projectile question. It actually asks something that we haven't done, and that's going from the speed stated in terms of magnitude and angle into vector form. But hopefully you can work that out. It's just going to be 800 cos 60 in one direction, 800 sine 60 in the other. But yeah, that's a good question to have a go at. And then this question here is another one of these ones where you've got acceleration which is not due to gravity. So those two are probably worth having a go at, although question 8 is really quite tricky. But yes, so page 89, I do question 9 first, and then question 8. I might do a worked solution for question 9 and post that, because that's quite a long question. But please, I'm checking my emails, and I'm happy to answer any questions you have about those. Other than that, take care, and I'm off for a couple of days now. Still be checking my emails, but I'll do the next videos at the end of the week. Take care.